Today we talk about section 10.5, Fourier Series. So before we talked about the Taylor series. With Taylor series, we approximated a function using powers of x minus a. For Fourier series, we approximate a function using sines and cosines of the type sin kx, cosine kx. Since these functions are periodic, we can only hope to approximate periodic functions. So we will attempt to approximate f with a sum of trigonometric functions of the form a0 plus a1 cosine x plus a2 cosine 2x plus a3 cosine 3x and plus an cosine nx plus b1 sin x plus b2 sin 2x plus b3 sin 3x plus bn sin nx. Fnx is called the Fourier polynomial of degree n, even though it isn't actually a polynomial. Fnx is called the Fourier polynomial of degree n. The numbers a k, b k are called the Fourier coefficients. Note that since all the functions cosine kx repeat every 2 pi, so must the original function fx. For such a function, there is a formula for the Fourier coefficient which gives a good approximation to f. The Fourier coefficient for periodic function of period 2 pi. So we have the coefficient a0 is 1 over 2 pi, negative pi 2 pi fx dx. Note that this a0 is simply the average value of f on negative pi 2 pi of f on negative pi 2 pi. This is a0. The ak is 1 over pi, the integral from negative pi to pi fx cosine kx dx. This k is positive. bk is 1 over pi, negative pi to pi fx sine kx dx. This k is also positive. So now we look at an example. Find the Fourier polynomials. So this example, construct successive Fourier polynomials of the square wave for f or period 2 pi given by this function fx. It's a piecewise defined function. So we first graph the function fx. 0 and 1. Negative pi pi. So when x between negative pi and 0, f(x) is 0. So negative pi is included, 0 is not included. When x is between 0 and pi, it's 1, 0 included, pi is not included. Then if it period 2 pi, right, it repeats this pattern. Repeat. So we want to find its Fourier polynomials. Fourier polynomials f(n)x. The formula is here. We need to find its Fourier coefficients a0, ak, bk. Now a0 is the average value on negative pi to pi. So we can guess that a0 should be 1/2. Now we take a0 is, by the formula, it's 1/2 pi from negative pi to pi f(x) dx. Because f(x) is 0, f(x) is 0 when x is between negative pi and 0. So have this integral can be written as negative pi to 0 from f(x) to dx plus 1/2 pi 0 to pi f(x) dx. So the first integral is 0 plus 1/2 pi. f(x) is 1 between 0 and pi. So dx. So this is 1/2 pi times pi. So it's 1/2. A0 is 1/2. So we confirmed our guess. So next we find ak, bk. So ak is 1/pi integral from negative pi to pi f(x) cosine kx dx. This is also the formula for ak. K is positive. So we already know f(x) is 0 between negative pi to 0. So this integral is 1/pi. It's 0 to pi. Sine f. So not the sine, it's cosine. f(x) is 1 on this interval. It's cosine kx dx. So this is to find the antiderivative. It's 1/pi sine kx over k. And this k is from 0 to pi. So we got this is 1/pi. Then sine k pi divided by pi minus sine 0 divided by k. K is now 0. So this is 0. 0. Sine k pi is 0. And sine 0 also 0. 0 minus 0 is 0. Then find bk. bk is 1/pi over the integral from negative pi to pi f(x) sine kx dx. This is also using the formula for the Fourier coefficient bk. And this is 1/pi. It's from 0 to pi. Now f(x) is 1, so it's sine kx dx. So find the antiderivative of sine kx. It's negative 1/k cosine kx. It's k from 0 to pi. So it's 1/pi. When x is pi, we get negative 1/k cosine k pi minus negative 1/k cosine 0. So we got this is 1/pi. So minus positive, cosine 0 is 1. So it's 1/k. 1/k. The minus 1/k cosine k pi. 1/k take out. So it's 1 over pi k, 1 minus cosine k pi. So the cosine k pi, if k is an odd number, for example, k is 1, when the cosine pi is -1. So have cosine k pi is, if k is odd, so it's -1. If k is even, for example, cosine k is 2, so cosine 2 pi is 1. So we got the bk. bk is, k is odd, cosine k pi is -1, so it's 2 over pi k, and this is k is odd. K is even, cosine k pi is 1, 1 minus 1 is 0, and this is the case, k is even. K is even, bk is 0. So from this, we see that f1x it's a0 plus a1 cosine x plus n is 1 plus b1 sine x. So this is a0, we know what is it? A0 is 1/2. A0 is 1/2. Then plus a1. AK is always 0, right? So it's 0 times cosine x plus b1, k is odd, so it's 2 over pi k sine x. K is 1, 2 over pi sine x. So this is 1/2 plus 2 over pi sine x. This is Fourier polynomial of degree 1. Then f2x, similarly, we have f2x is a0 plus a1 cosine x plus a2 cosine 2x plus b1 sine x plus b2 sine 2x. So we know ak is 0, so they are all 0. So this is a0 plus b1 sine x is 2 over pi sine x plus b2, 2 is even. 2 is even, bk is 0, so it's 0 times sine 2x. So we get a0 is 1/2, 1/2 plus 2 over pi sine x. So we see f1x is the same as f2x. So next we find f3x. f3x, so based on the f2x, we need to add a3 cosine 3x and b3 sine 3x. a3 is 0, so it should be 1/2 plus 2 over pi sine x. So b3 is odd, so it's 2 over 3 pi. 2 over 3 pi sine 3x. So similarly, we get f4x is the same as f3x. And it's also this one. So if it's f5x is add 2 over 5 pi sine 5x to f3x. So this is the example. Find the Fourier polynomials. We just need to find the Fourier coefficients a0, ak, bk by those formulas for the Fourier coefficients.